Hello, Blackstone astronomers. Welcome to your first online space science lesson. Your lesson today is our first lesson in our stars unit, and it's about stellar magnitude. Stellar magnitude means size, how big. So when we talk about stellar magnitude, we're actually talking about how bright a star is. So let me start by introducing you to a man named Hipparchus. Hipparchus is this ancient Greek astronomer. We've seen lots of ancient Greek astronomers before. So here's Hipparchus. Hipparchus is living in ancient Greece, and we're talking about the year 130 BCE. Right? So well over 2,000 years ago. And what Hipparchus is doing is that he is looking into the sky at stars. Nice and simple. But one thing that Hipparchus is going to do, he's very different from the astronomers who were trying to come up with models of the solar system and planets. Hipparchus is interested in cataloging stars. Now, when we talk about cataloging stars, we're not talking about, clothing catalogs or shoe catalogs. When we talk about cataloging stars, we're talking about creating a database, although obviously he doesn't have a computer, but a log or a list of all the different stars, and he's interested in listing the brightness of different stars that he sees. We're going to call this the magnitude. And he comes up with categories. So he says, okay, the brightest stars out there, the really, really bright ones, so I'm going to make this star relatively big, he's going to call a star with a magnitude of 1. The next would come a star with a magnitude of 2, not a magnitude of small. And this star looks a little less bright. Next, we would have a magnitude of 3. And again, this star is slightly less bright. And this will keep on going and going and going. So one thing you have to remember with magnitude for stars is that the smaller number actually represents the brighter star. Now, it turns out that now we know that the human eye, so let me draw an eye, can tell the difference between two stars if one is at a minimum 2.51 times brighter than the other. So what does that mean? It means that if I had two stars, right, we'll call this star A and star B. Now, if star A is twice as bright, so let's say 2 times as bright, our eyes on Earth, they're kind of weak, right? They're not nearly as good as telescopes. Can't tell the difference. So again, if star A is twice as bright as star B, our eyes will see them as the same. Our eyes won't be able to tell which one's brighter and which one's fainter. However, if star A is 3 times as bright, then yes, our eyes will be able to tell that star A is brighter than star B. And the reason for that is that the threshold means sort of the minimum number for something to happen. The threshold is 2.51. So our eyes can tell a difference in brightness between two stars once one star is 2.51 times brighter than the other. So if we bring this back to Hipparchus, what this means is that stars that Hipparchus decided were magnitude of 1 in reality are actually 2.51 times as bright as stars with a magnitude of 2. And stars with a magnitude of 2 are actually 2.51 times as bright as a star of magnitude 3. So let's try and apply this information I just gave you into a problem. So I've got 2 stars. One star over here and one star over here. Right? Let's call this star Ella, I'm just making up these names, and this star Ben. Our stars have people names. So I'm going to say that Ella is a star with a magnitude of 5. Right? And I'm going to say Ben is a star with a magnitude of, let's say 8. Now remember, this number has to be bigger if it's less bright, because the larger magnitude number means a bigger star. So how do I figure out how many times brighter in reality Ella is than Ben? Well, let's see. I'm just going to map out the magnitudes. So again, this is the bright end of the scale because it's lower numbers, and this is the dimmer end of the scale. So I've already shown you how each jump in magnitude represents a change of times 2.51. So here, Ella would be 2.51 times as bright as a star that had magnitude 6. A star with magnitude 6 would be 2.51 times as bright as a star of magnitude 7. And a star of magnitude 7 would be 2.51 times as bright as a star of magnitude 8. So if we want to figure out how many times brighter Ella with magnitude 5 is than Ben with magnitude 8, what we do is 2.51 times 2.51 times 2.51. And if you plug that into your handy-dandy calculator, you should get the number 15.81. Now, you might have noticed that 2.51 times 2.51 times 2.51 is the same thing as writing 2.51 to the power of 3, which will also give you 15.81.